Hello everyone, hope all of you are doing great, and in today's video we are going to discuss the classified paper 1 unit 9, which is all about sequences and functions. If you notice, it's paper 1, so calculator is not allowed. The first question here says to you, Blassie thinks of a number and multiplies it by 3. She then subtracts 6. Her final answer is 15. Work out the number Blassie started with. If we think about this in an organized way, let's think about the number that she started with as x. What did she do to the number? She multiplies it by 3. Then what happens to the number after that? Then she subtracts 6. Her final answer was what? Was 15. So what is the number that she was thinking about? I'm going to go backwards, but with the inverse operations. So to find the number that Blassie was thinking about, I'm going to write over here x equals 15. I'm going to start with the number that I already have, the answer. Then going backwards, it is plus 6. Then the answer at the end is you're going to divide it by 3. So knowing that, it is going to give you exactly 21 divided by 3. The answer is going to give you exactly 7. Draw a ring around the function that corresponds to the rule in the box. Multiply by 4. So let's think of x. You multiply it by 4, so it's going to be 4x. Then subtract 2. So that's it, 4x minus 2. This one. Here are the first 3 diagrams in a sequence. They want you to draw the next diagram in this sequence on the grid. If you noticed over here, we have 3, and at the top 1, and at the bottom 1, then 4, and then at the top here, you got 3, and then 3. So if you noticed, you're going to just find also here, you have 5, the first column, and at the top of the horizontal, you have 4, and then 4. So the next one is going to be 6, and then 5 up and 5 down. So I'm going to have over here, we add 1 row and 1 column for the x's. So let's do it. Add 1 row down and add 1 column as well. So instead of 1, 2, 3, 4, 5, it's going to be 1, 2, 3, 4, 5, 6. And instead of having 4, they're going to be 5. 1 is already done. 2, 3, 4, 5. And at the bottom also the 5. That's it. And in the middle, fill the rest with circles. Let's continue. Explain why the number of circles in diagram 5 will be 25. The number of circles in diagram 5, why is it going to be 25? Well, if you noticed, the diagram 1, the number of circles is 1. The diagram 2 has number of circles 4. Diagram 3 has number of circles 9. So diagram 5 will have number of circles 25. No, sorry, do not get it. Yeah, if you noticed, you're going to find out that these are the square numbers. You just squaring the number of diagrams. So it's diagram 1, 1 squared is going to give you 1. The number of circles is 1. Diagram 2, number of circles is 4 because it's 2 squared, 4. 3 squared, 9. 5 squared is 25. So you're going to explain this here because the number of circles is the square of diagram number. Let's continue. Find an expression for the number of crosses in diagram N. An expression that means that they want the nth term. That's the expression that they want for the sequence, the nth term, but they said the number of crosses. The number of crosses over here, you're going to find, I'm going to choose a different color. The number of crosses here is 5. While here, the number of crosses is, you got here 4 and 4 is going to be 8. And the number of crosses here, you're going to find that it is 13. So what is happening? If you noticed, you're going to find that what is happening every time? I'm adding what? Here, I added 3. Then here, I added 5. So what is happening? What is going to happen there? 1 second. Here, 1, 2, 3, 4. And here is 8. 8, and I've got here 3. It is 11. Sorry, I'm sorry. It is 11. So added also 3. So what is happening every time? I'm adding 3 every time, Mr. For the number of crosses. So it is definitely a linear sequence. So it is 3n. And what is term 0? What is going to be there in term 0? Term 0 is going to become just a 2, right? So it is 3n plus 2. If you try it, you wanted the number of crosses in the first diagram. 3 times 1 is 3 plus 2 is 5. The second diagram, 3 times 2 is 6 plus 2 is 8. The third diagram, 3 times 3 is 9 plus 2 is 11, and so on. So it is a linear sequence. So 3n plus 2. 3n plus 2. Here, they're giving you already the expression. You multiply the input by 10, then you add 2. So 3 times 10 is 30, plus 2, 32. 7 times 10 is 70, plus 2 is 72. 4 times 10 is 40, plus 2, 42. But if I have 2 emister, so it just means that you're going to say 10x plus 2 is going to give you already 2, is equal to 2. And solve the equation to find x. So 10x equals 0. Divided by 10, give by x equals 0. I want to try it. Okay, no problem. 10 times 0, 0 plus 2 is 2. That's it. Next, a sequence begins this way. Write down the term-term rule. Here, what happened? We minused 9. Then here, what happened? We plused. Okay, here it is not minusing and plussing. They are and they're not requesting the nth term. They're not requesting the nth term. They are requesting from you the what? The term-to-term rule. So we don't want to get confused. Don't get confused like what was going to happen with Mr. Ahmed right now. So they are requesting the term-to-term rule. What is happening every time? Term to term. You multiply this by 2, negative 2. Then here you multiplied it by negative 2 again. And here you multiplied it by negative 2 again. So it is multiplying or multiply by negative 2. Write down the next two terms. Multiply this by negative 2 is going to give you negative 96. Multiply this negative 96 by negative 2 is going to give you positive 192. Write an algebraic expression for each function machine. One has been done for you. N times 3 is 3n. N plus 4 is n plus 4. N times 5 is 5n. But then minus 3, so minus 3. Complete the function machine for the statement below. Hassan or Hassan thinks of a number. He divides the number by 4, so divide by 4. And then adds 2. Then adds 2. The answer is 7. Work out the number Hassan was thinking of in part B. So I'm going to work it backwards. 7 minus 2, the answer multiplied by 4. 7 minus 2 is 5. times 4 gives you 20. Pattern 1 is 3 matches, while pattern 2, you're going to find it 7 matches. So this is 3, this is 7, and pattern 3 is going to give you 11 matches. So what is pattern 4? You need to draw the same way, but you need to draw, I'm adding here a 4, then I added here a 4, then you add here a 4. 15 matches, or 15, what are they calling them? Rods, sorry. 15 rods. That's pattern 4, because every time we're adding a 4, complete the statement when the pattern the number increases. Definitely, you must draw them here, okay? You must draw them this way. This way, I drew 3 by 4 is 12. Then you put over here 1, 2, 3 at the top. So you have the 15. Definitely, you need to draw this a little bit bigger. All right, when the pattern number increases by 1, what is happening? The number of rods increases by 4. Work out how many rods will be used for pattern 7. Mister, this is a linear sequence. The nth term is 4n because every time we're adding a 4, and term 0 is going to be -1, so 4n minus 1. The 1 to the 11th, if you want to try it first, so try it. 4 times 1 is 4, minus 1 is going to be 3. Done. 4 times 2 is 8, minus 1 is going to be 7, and so on. So it works. Good. So for pattern 7, 4 multiplied by 7 is 28. 28 minus 1 is going to give you 27. The first three terms of the sequence of 3n squared minus 7n are -4, -2, 6. Write down the first three terms of the sequence. This sequence. Just as normal, 3 multiplied by 1 squared minus 7 multiplied by 1 plus 3. This is going to give you 3 times 1, which is 3, minus 7, which is -4, plus 3, which is going to be -1. I need a mister for 2, the second term. So 3 times 4, 2 squared. 3 times 2 squared, which is 3 times 4, is 12. 12 minus 14. 7 times 2 is 14. Then plus 3. Then you're going to find that 12 minus 14 is -2. -2 plus 3 is going to give you 1. After that, what is going to happen? After that, 3 squared. So 3 times 3 squared, which is 3 times 9. 3 times 9 is 27. Minus 7 times 3, which is 21, plus 3 is going to give you exactly 6 plus 3, which is 9. Let's continue. Let me erase this. Here is a sequence of numbers 80, 40, 20, 10. Find the term-to-term rule for this sequence. You're minusing every time what? I minus here 40. Then I minus here 20. Then I minus here 10. Right? Yes. But mister, it's not working this way. Subtraction and addition are not working. Why? Because in the term-to-term rule, I need the same thing to happen every time. So it's not going to work. It's not addition or subtraction. And again, this is not the nth term. So how can we do this? What is happening every time, mister? If it is not subtraction, then it's definitely division because the numbers are getting smaller. So subtraction did not work. So divided by 2, divided by 2, divided by 2 worked. So divided by 2. Here is a sequence 7, 11, 15, 19, 23. Find the nth term. Nth term, I must find the difference. Here, we added a 4, added a 4, added a 4, added a 4. So it is a linear emitter, linear sequence. So it is 4n. But term 0 minus 4 gives you 3. So it is 4n plus 3. The nth term of a sequence is this. Find the seventh term. 7 squared is 49. 49 and 5 is 54. Here are the first 5 terms of a different sequence. Find an expression for the nth term of this sequence. What is happening? I added here 3. Then I added here 5. Then I added here 7. And I added here 9. The first difference is not the same. Then definitely this is what? Added a 2, added a 2, added a 2. So definitely this is quadratic. Quadratic. So it is n squared. If n squared if n is 1, to check for the first term, n is 1. So 1 squared. 1 squared is 1. How many do I need, Ashen, to go to 0? It is minus 1. Let's try for the second term. 2 squared is 4, minus 1 is 3. 3 squared is 9, minus 1 is 8. It worked. Let's continue. Here, the final digit of 7 to the power of n is 1. They've given you here 7 to the power of 1, 7 to the power of 2, 7 to the until 7 to the power of 7. And they're telling you that the final digit here is 7, the final digit here is 9, until the last one, the final digit here is 3, and so on. So, they're telling you here that the final digit of 7 to the power of something is 1. Write down a possible value of n if n is greater than 7, which means don't go and say it is n, it's 7 to the power of 4, because they said n is greater than 7. So you must go after that. All right, this is paper 1. So it is not possible that you go over there and you try, for example, 7 to the power of 8 and see if the final digit is going to be 1 or not. It's not paper 1. And definitely, it's not paper 2. And definitely, we're not going to keep doing 7 times 7 times 7 times 7, 8 times. And I'm not going to even take that and multiply by 7. Yes, it might be possible. And someone might think about 7 multiplied by 3 is 21. So definitely, the units place is going to have 1. This is one way to think about it. But there is a pattern, actually, that we need to realize over here. What is the pattern? If you notice that the final digit of the first, when it's 7 to the power of 1, you're going to find that the final digit is 7, then 9, then 3, then 1, then goes back to 7, 9, 3, 1. The final digit is going to be 1 in the next one, the next pattern. So it is 7 to the power of 8. 7 to the power of 8 is going to have a final digit 1. How did we know this? We noticed the sequence. 7931, then 7931, then 7931, the final digit. This is going to help us a lot in question B. Use patterns in the table to find the final digit of 7 to the power of 22. Oh my God, if I did not notice the pattern, then I will never be able to answer this question. It is impossible to answer this question if you do not notice the pattern. So 7 to the power of 22, top mister, how can I use the pattern? You should know that the fourth always ends with 1. Like a multiple of 4. Like I got 7 to the power of 4 will always end with 1. 7 to the power of 8 ended also with 1. So 7 to the power of 12 will end in 1. 7 to the power of 16 will end with 1. 7 to the power of 20 will also end in 1. So 7 to the power of 21, what is after 1? If it ends with 1, then next it will end with 7. will end in 7. 7 to the power of 22 will end after the 7 is going to be 9, will end in 9. So again, I used the pattern 7 to the power of 4, after it 7 to the power of 8, 7 to the power of 12. I used the pattern, knowing that the multiples of 4 in the power, the multiples of 4 end with 1, 1, 1. So until 7 to the power of 20 will end in 1. So 7 to the power of 21, I got 7, then 9, then 3. So it's 7, 9 is 7 to the power of 22, will end with a 9. The final digit is 9. A function is defined by this function machine. Input is multiplied by 2, then cube, then you get the output. Complete the table. 5 multiplied by 2 is 10. Then cube it is going to be 1000. 3 over 2 multiplied by 2, simplify 2 by with the 2, then is going to be 3 left. So 3 over 2 times 2 is just 3, or 6 over 2, which is just also 3. Then you cube it, is going to give you 27. Calculate the input when the output is negative 64. The output is negative 64. We're going to work backwards. So it is negative 64, but cubic root of it. Let me just cubic root of negative 64. And after that, instead of multiplying it by 2, you're going to divide by 2. Cubic root of negative 64 is going to give you exactly negative 4. Divided by 2 is going to give you negative 2. So here you should write over here, negative 2. The term-to-term rule of a sequence is multiply by 2. The first term of the sequence is A. The sum of the first term and the third is 35. Work out the sum of the first two terms. Okay, this question is a little bit tricky. But look at that. You must use algebra this lesson, in this question. The thing to the first term is A. So I'm going to write the first term as A. They said to you that the term-to-term rule is multiply by 2. So the second term is going to be A multiplied by 2, which is 2A. The third term is going to be what? Multiply by 2. So 2A times 2 is 4A. Work out the sum of the first term and the first two terms. Oh, but they said the sum of the first and the third is 35, which means the first, this is first, this is second, this is the third. The sum of the first and the third, so they said A plus 4A equals 35, they said. So 5A is 35. So A is just 7. Now we found A. It is 7. But do they want A? What A is equal to? No, they want you to work out the sum of the first two terms. This term, which is 7, and the second term, 2 times 7, which is 14. So add them up. It is 7 plus 14, which is 21. What is happening here in this pattern? Look at this. It's a sequence. Mister, how come it's a sequence? Here's a sequence of calculations. Yes, if you noticed every time over here, I'm adding what? I added here 2. 1 plus 2 is 3. Plus 2 is 5. Plus 2 is 7. Plus 2 is 9. Plus 2 is 9. So 9 plus 2 is 11. That's how we reach the 11. But what is happening in the 7? 7 plus 1 is 8, plus 1 is 9, plus 1 is 10, plus 1 is 11, plus 1 is 12. What is happening to the 2? 2 plus 2 is 4, plus 2, 6, plus 2, 8, plus 2, 10, plus 2, 12. 1, 2, 3, 4, 5, 6. 5 became 16, so we added 11. Then we added 11. Then we added 11. So we add 11, it becomes 60. That's it. Jamila makes this sequence of patterns using white counters and black counters. Black counters, complete these sentences. The first one has been done for you. The number of white counters in pattern 4, they counted it. You're gonna find 12 and 3 is 15. They said 15. The number of white counters in pattern 5, what is it going to be? Mister, let's draw over here, right over here. Here I had 0 white counters, then 3. Then over here we had 8. Then over here we had, this is 4. Then 8, 12, 15. So what is going to be next in pattern 5? I added here 3. We added here 5. Then we added here 7. So in pattern 5, what are we going to add? Add 11, add 9, add 3, add 5, add 7, add 9. So 15 will become 24. That's pattern 5. The number of white counters in pattern 100, that's going to be impossible to find without the nth term. If you noticed, this is a quadratic sequence. Added a 2, then added 2. The second differences are the same. So it is definitely n squared. But n squared, if I say 1, 1 squared is 1. What do I need for the 1 to be 0? So minus 1. Now try it again. 2, if I went for the 2. 2 squared is 4. Minus 1 is 3. It worked. So for the white counters, I have nth term n squared minus 1. They wanted a hundredth, pattern 100. So I'm going to say pattern 100 is 100 squared minus 1. 100 squared, I have 2 zeros. They're going to be 4 zeros. 100 times 100, 4 zeros, minus 1. So this is going to become 9,999. 10,000 minus 1 is 9,999. Write an expression in terms of n for the total number. Guys, if you face any problem with any question or you feel like you got like 50% of it, watch it again, you will get it. Or you will get more of it. Write an expression in terms of n for the total number of counters in pattern n. All right. That means that they want the nth term for the total number of counters. So what is the total number of counters? Well, instead of wasting time on erasing, I'm going to use a different color. Here, the number of counters was 2. It became 5. So we added 3. Then the 5 became the number of counters. Here is 5. Here is 2. We added 3. Here, the number of counters is, you're going to find it's 10. So what happened? We added 5. Then from 10, it became what? You're going to find it is 12. It became 13. So we added 8. What is happening? It is still quadratic sequence because the first differences are not the same. The second differences are the same. All right, and so on. So if you find that the second differences are the same, then it is quadratic. So the nth term is definitely n squared. So I'm going to write n squared. N squared, try 1 squared. It is 1. How many do I need for it to become 2? I need 1 more. So it's n squared plus 1. Now let's try it for the second pattern. 2. 2 squared is 2. Is 4. 4 plus 1 is 5. So it worked. 3 squared is 9. 9 plus 1 is 10. It worked. So it's just a normal quadratic sequence. You just needed to put the number of counters 2, 5, 10, 13, And then you find the nth term using the first differences, the second differences, the quadratic sequence. It is a quadratic sequence. Find the nth term as normal. So n squared plus 1. Question 17. The first term of a sequence is 3. The term-to-term rule of the sequence is a square, then subtract 5. Find the third term of the sequence. So 3 square becomes 9. Minus 5 becomes 4. Square becomes 16. Minus 5 becomes 11. So the third term is 11. All right, question 18. Here are the nth term rules of the sequence of three sequences. Sequence A, 7n. Sequence B, 5n minus 1. And sequence C, 20 minus 3n. All right. Which one of them is a term in the sequences? We need to match. Is 24 a term in in sequence A? So can I find that 7n equals 24? 7 times something gives me 24? No. 7 times something equals 35? Yes. Is it even 11? No. 7n equals 11, you're not going to find it. 7 times something equals 35? Yes. So definitely 35 is in sequence A. 5 multiplied by something minus 1 gives you 24? Yes. طب how can I know it, mister? If you do 5n minus 1 equals 24, let's solve the equation. 5n equals, send the negative 1 there, positive 1 becomes 25. Divide by 5, n equals 5. Yes, there is actually a term, and it's the fifth term. It's going to give you 24. So 5n minus 1 sequence B has a term that is equal to 24. Sequence B. And 11, you're going to find it there. If you want to try it, 20 minus 3n equals 11. So you're going to find negative 3n equals, send the negative 20 there, becomes negative 9. You have n equals 3. Yes, mister. It worked. So just take this and try it. It is obvious that for 7n, 7 multiplied by something, it gives me 35 is the only thing that is going to work. 7 times 5 is 35. Nothing multiplied by 7 gives me 11. Nothing multiplied by 7 gives me 24. So it is obvious that Mr. 35 is a sequence in is a term in sequence A. You try the rest and you find your final answers. This is similar to a previous question. I added here 1, then 1, 2, 3, 4. They want you to find the next calculation in the sequence, adding a 1 every time. 1, 2, 3, 4, then 5. 5, 6, 7, 8, 9. 2, 3, 4, 5, 6. 3, 4, 5, 6, 7. Negative 1 became 0, then 1, then 2, then 3. Use the sequence to work out 37 multiplied by 41 minus 38 times 39. Well, if you noticed here, look at this. If you noticed here, when we jumped from 1 to 4, we added 3. So when you jump from here, you want to find the answer, you just simply add 3. It will give you the answer. Negative 1 plus 3 will give you 2. So if you want to jump, from 1 to 37, you add 36. So just add 36. It will give you the answer. Negative 1 plus 36 is positive 35. That's it. Positive 35. A linear function maps input numbers to output numbers. Complete the input-output table for this function. All right. 1 becomes 4. The 2 becomes 10. The 5 becomes 28. 5 becomes 28. The 10 will be what? And the n will be what? Well, here is the tricky part. Actually, to find 10, it should be very easy. Because if you noticed that every step, we're adding what? Every step over here, you're adding 6 over there in every step. So here, for the next step, there is just lagging in my laptop. I don't know where the problem is. Added here, how many steps? Mister, this is here, you're not adding it one step, you added 3 steps. So I add here 18. So that's how it worked. 18. So this became 28. So every step, you're adding a 6. Here, I jumped 5 more steps. So I add over here 30 because I jumped 5 steps. 5 times 6 is 30. So this is going to become 58. If this is what you noticed, you're going to get 1 mark. It is going to be very hard to find n. And at least you should get this 1 mark. You should notice that every step we're adding a 6 to the other side. So here 3 more steps, I add 18. This level is average. Medium level. Okay, but the n is a little bit hard, to be honest with you, and a little bit tricky. You should know, or you should notice that the n, what happened here is that you multiply by 6, and then you minus 2. So from the input to the output, I multiplied 1 by 6, so it gives me 6. Minus 2, it gives you 4. 2 times 6 is 12. Minus 2 is 10. 5 times 6 is 30. Minus 2 is 28. 10 times 6 is 60. Minus 2 is 58. So n times 6 is 6n minus 2. So 6n minus 2. Many of the students found the 58 through this way, but they got stuck with the n. They didn't know what to do. A few students only, they noticed that that term, the input and the function machine. They knew that I multiply the 1 by 6, then we minus 2, so I multiply the n by 6, and I minus 2. The function y equals x minus 3 all squared can be represented by this function machine. Input is x, then you minus 3, then you square, then the output is y. Find the output if the input is negative 1. The input is negative 1, so negative 1 minus 3 is negative 4. Square it, then it's 16. Find the 2 inputs that give an output of 9. Output is 9, so let's erase this negative 1. If the output is 9, I'm going to go backwards, so I'm going to say 9, but square root it, right? Square root of 9. Then, instead of minus 3, I'm going to say plus 3. This will give you the input. But they're saying 2 possible inputs. Well, what is the square root of 9? Square root of 9 can actually be either positive 3, we agreed before that square root has 2 answers, either positive or negative 3. So I can say here positive 3 plus 3. Or square root of 9 can be negative 3 plus 3. In this case, the input is 6. In this case, the input is 0. So let's try it. So here is the tricky part is remembering that square root of 9 is equal to positive or negative 3, because 3 squared is 9. طب negative 3 squared also 9. So that's why I put here, it could be 3 plus 3 or negative 3 plus 3. طب I want to try it, Mr. If the input is 6, 6 minus 3 is 3. Squared is going to give you what? 9. What they requested, the output is 9. The input is 0. So 0 minus 3 is negative 3. Negative 3 squared is positive 9. The nth term of a sequence S is 2n plus 5. The nth term of sequence T is 3n minus 6. Show that 91 is a term in sequence S. 91 is a term in sequence S. I'm going to take sequence S, which is 2n plus 5. And I will say that it is equal to 91. And I will solve the equation. If n is a whole number, then 91 is a term in the sequence. So 2n equals minus 5 is going to become 86. So n equals 43. That's how we can show that 91 is a term in the sequence. It is actually a term in the sequence, and it is the 43rd term. They want you to show that 91 is not a term in sequence T. Sequence T is 3n minus 6 equals 91. So 3n equals 85. Sorry, it's send it over there plus 6, so 97. So you're going to find that n equals, you're going to find that if you do the division, you're going to find that this is what? This is not divisible by 3. So you're going to find a decimal in there. You will find that it is 3, 2.3 dot notation above the 3. You're going to find that it's endless. 32.3 dot notation above the 3. So you will show that it is not a term in the sequence. It is actually between the 32nd and the 33rd term. Find the value of the term that is in both sequences and is in the same position in each sequence. Oh, Mr. They're saying to you that there is a term in both sequences and the same position in each sequence. Okay, that means what? It means 2n plus 5 gives you the same value as 3n minus 6. So I'm going to take them and write them down there, but they are equal to each other. 2n plus 5, 3n minus 6. 2n plus 5 equals 3n minus 6. And you solve. I take 2n to the 3n, and I get the negative 5 to the 5, negative 6 to the 5. So 5 plus 6, 3n, 2n, get it there, minus 2n. So 11 equals n. So it is the 11th term. The 11th term is the same in both sequences. If you leave it this way, you take 1 mark. So I want both marks. You need to find the value of that 11th term. Value of 11th term. Remove n and write 11 in any of them. So 2 multiplied by 11 plus 5 from the nth term of one of the two sequences. 2 times 11 is 22. 22 plus 5 is 27. Now if I wanted the other sequence, 3n minus 6, the other sequence, try it. 3 times 11 is 33. 33 minus 6 is also 27. So the value of the term that is in both sequences and it has the as and is in the same position, the value of it is 27. Repeat this part again if you would like to get it more. Repeat the answer to this question again if you would like to. Here are the first four terms in a sequence. Find the next term and find the nth term. Let's see first if this is linear or quadratic. I added here a 7. Well, if you do it this way, you're gonna find that it is a lot, it's so tricky. I added here a 7, and then you think about it, you're gonna find out I added here 19. And then you think about it, I added over here, that's something that is much bigger. I added over here 37. What is going on? That is going to be very hard. Yes, exactly. It is very hard and might be even impossible. You should actually notice from the very beginning that this is a list of the cubic numbers. These are the cube numbers. 1 cubed is 1, 2 cubed 8, 3 cubed 27, 4 cubed 64. 5 cubed is 25, 125. It's list of cube numbers. Find the nth term is n cubed. Here, question 24. Here are some inputs and outputs of the same function machine. Input is 5. The output is 2. Input is 20. The output is 8. All right. If you go down, you're going to find that this question is worth 2 marks. Many students, they got 1 mark. Why? Because they could find this, but they couldn't find this. How did they find this? They said, Mister, I'm going to multiply by 4. If you multiply this by 4, it gives you 20. You multiply this by 4, gives you 8. Then I divided this by -2. Then I will divide that divided over here by -2. It gives you -4. So what happened here is that I divided by 4. It gave me -1. Then I'm going to divide here by 4. It gave me -10 over 4, which is simplified to -5 over 2, which is simplified to -2.5 as a mixed number. So they just noticed that here they divided by 4, then they divided here by 4 as well. It gave them -2.5. Good. That's how they got the mark. Many other students, they could not actually get what happens to n. And you should know or note, I know that it is tricky to notice this, but if you noticed, you're going to find that the 20 got multiplied. I'm going to change the color of the pen. The 20 got multiplied by 2, then divided by 5. So the 20 got multiplied by 2 is 40. 40 divided by 5 is 8. Then the -2 also multiplied by 2, then divided by 5. So -10 times 2 is -20. -20 divided by 5 is -4. Then you multiply this also by 2, then you divide by 5. This gives you, multiplying this by 2 gives you -5. Doubling it, 2.5 is 5. So -5 divided by 5 is -1. Then multiply this by 2 and divide by 5. It's going to give you 2n over 5. Let me remove this cross. 2n over 5. Or you might find it in the mark scheme 2 over 5n. Both are correct. The term-to-term rule of a sequence is square and then add 2. The first term of the sequence is 3. Find the second term of the sequence. All right, the first term of the sequence is 3. The term-to-term rule of the sequence is square. 3 squared is 9. Then add 2, so 11. 11. Find the fifth term of each of the sequence in the table. 5 over 4 is 5 over 4. Or you can write it 1 and 1 over 4. Or you can write it 1.25. Any of them is acceptable. N squared, the fifth term is going to be 25 minus 11 is going to give you 14. 5 cubed is 125. Here is a sequence with nth term n squared plus 4. Find the 12th term of this sequence. The 12th term of this sequence. So they said the nth term is this. All right, so the 12th term, 12 squared, is 144. So 144 plus 4, which is 148. Here is a different sequence. By comparing this sequence, by comparing this sequence to the sequence in part A, find an expression for the nth term of this sequence. All right, so they wanted the nth term. Mister, if you noticed over here, this is n squared plus 4, but they added the 2, added the 2, added the 2, added the 2. The 20 became 22, 29 became 31, 13 became 15. So it is just the same expression as the first, n squared plus 4, but they added a 2 to the answer. So it is n squared plus 6. Even if you do it on your own without depending on sequence A, if you do it on your own, you're going to find that I added over here a 4, a 3, added over here a 5, add over here a 7. Mister, it is going to be a quadratic sequence. So it is n squared. But 1 squared is just 1. How many more do I need for it to become 7? Add 6. So it's n squared plus 6. But no need to do any of this. Why, mister? Because I already know they told me, look at the sequence above. I found that it's n squared plus 4. But what is happening, the only difference is that every time I added 2 more to the previous sequence. So it's n squared plus 4 plus 2, which is n squared plus 6. The mapping diagram over here represents the function y equals 5x squared. The input is 2. So 5 times 2 squared, which is times 4, which is 20. So half, what is half squared? Half squared means half times half, which is quarter, 0.25. That's 0.5 squared. Multiplied by 5. So I got here 5 multiplied by quarter. You're going to find that it is exactly going to give you 125, but I have 2 decimal places, so 1.25. But Mister, here they've given us the y and they want the x. So they're saying to you 5x squared is equal to 80. Send to the 5 and instead of multiplication, send to their division. So x squared equals 80 divided by 5 is going to give you exactly 16. So x is what? X is the square root of 16. Oh, what is the square root of 16? Could be 4, could be negative 4, positive or negative 4. That's it. Thank you so much, everyone, and see you in another video.